Hi everybody, Mrs. Bolin here, and we're going to take a look at guided notes for standard 21 and 22, area and parts of figures, and this is day 1 of notes. So if we're talking about figures, let's first talk about perimeter. What is perimeter of a figure? And perimeter is just our distance around a figure. And when I think of perimeter, I like to think of my backyard, and let's say I want to go around the perimeter or consider the distance around my backyard. This would be as if I was building a fence. So I like to think of perimeter as a fence. How much fencing would I need to go around my backyard to enclose the whole distance around so my dogs can't escape from my backyard? Let's talk about the units for perimeter. So let's say I was building a fence and we were taking measurements. We would maybe measure in the number of feet around my backyard, or maybe the number of yards around my backyard. And so for perimeter, we just use units. And maybe the units given to us are centimeters, inches, feet, right? It could be any of these units. Our directions now say to find the perimeter of each figure. So that means pretend as if this was the awkward shape of my backyard, and I need to come up with fencing measurements to go all the way around for this whole distance of my backyard. So what I would need to do is add up all of these individual distances. Notice, however, that along the top of my figure, I do not have a distance or a measurement labeled. Same thing with right here, along this right side of the figure, I do not have a distance labeled. So what I will need to do is first figure those out. If I look along the top of my figure, I may notice that from here to here along the top matches with right here. And here my distance was 3 units, so that means on the top it will also be 3 units. So in order to figure out the distance along the top, I'm using the distances along the bottom here to help me. And then you may notice that from here to here on the top of my figure matches with along the bottom of my figure. And the bottom says it's 8 units. So on the top, it must also be 8 units. And then over here, I can see I have 7 units. So along the top, it must also be 7 units. Now I just need to figure out distance along this right edge of my figure. And I may notice that if I use the left edge to help me, that from here to here is 6 units. So from here to here is 6 units. But I still need this little sliver right here. So if I look along the very far left edge, I see that this is 4 units and over here is 2 units. So if I do 4 minus 2, then this last little distance has to be 2. Now that I have all of the distances labeled around my figure, I can start adding them up. Just be careful, pay close attention to where you start. I'll start in this left corner. So I'll do 4 plus 3 plus 6 plus 8 plus 6 plus 2 plus 7 plus 2 plus 7 plus 8 plus 3. And you could just punch all of that into your calculator. And that would tell us our total perimeter. And for perimeter, we use capital P. So we can say perimeter equals. And when you punch all of those small distances into our calculator, we would get 56. Notice these lengths here weren't measured as a specific type of unit. It didn't say yards or centimeters. So for that reason, I'm just going to say units. You could write the word units. You could also write a lowercase u to show that our total perimeter is 56 units. At this time, I want you to take a look at You Try One. Go ahead, pause the video and see what you come up with. On You Try One, there were 2 distances around the figure that we had to figure out. Both of them ended up being 6 units. So then once I had all of the small distances around my figure labeled, then I could add them all up and I got a total perimeter of 80 units. Now that we've explored a little bit about perimeter, let's talk about area in a general sense. So area of a figure is no longer looking at the distance around the figure. Now we're looking at the flat surface inside. Flat surface inside a figure. And I like to think of this as grass, or like laying sod in your yard. So a few summers ago, my husband and I did put up a fence around our yard, looking at the perimeter of our yard. And we also did lay sod to cover the flat surface inside of the figure, or the flat surface inside of the fence, inside of the perimeter. So you can think of area as the grass. When we were ordering sod for our backyard and picking it up, we were looking at 1 yard by 1 yard squares of grass, and you call them square yards, and that's because area's units are units squared, or squared units. You would write it like this: units squared, or units to the second power, because for area you have 2 dimensions, which we will look at here in a moment, and so you end up getting square units. So that would be something like centimeters squared, inches squared, etc. So you could say square centimeters, square inches. Next, let's talk about this postulate. It says the sum of areas. All this says is that the area of the parts must equal the area of the whole. The area of the parts must equal the area of the whole. So this means that if you know a whole bunch of small areas, you could add them up or sum them up to find the area of the whole. Now that we've talked about area and perimeter in a general sense, let's talk about area and perimeter for a rectangle. So let's be specific and let's talk about the figure being a rectangle. So for the perimeter of a rectangle, one way you can think of it is just add up the sides, just like we did here at the beginning of our notes. You're looking at the distance around the rectangle, so you could simply add up the 4 sides of the rectangle. There's also a formula we could use for perimeter. So again, capital P for perimeter equals, and there's a top and a bottom that are going to have the same dimension in a rectangle. And then there's a left and a right side of the rectangle that are going to have the same dimension. So you could say that that's doing 2 times your base plus 2 times your height. Or another way you could write that is, instead of calling it base and height, you could say your perimeter is 2 times the length plus 2 times the width. Either of these would be fine. For area of a rectangle, now we're looking at the flat surface inside the rectangle. For area, we can use capital A. So my area, I will multiply the 2 different dimensions that I have for the rectangle. So we could say the area is going to be my base times my height. We're multiplying the 2 sides here. Or you could say, if instead of using base and height, you wanted to use length and width, you could say your area is length times width. Today, I'm going to use base and height when talking about a rectangle, but if you prefer to think of it as length and width, that's fine too. Let's look at our example B. Our directions say find the perimeter and area of each rectangle. So we do have a specific figure being a rectangle. And if I look at my figure, 3 of my sides are labeled. My top is not labeled. Real quick, I can go ahead and label the top as 1.8 because we've learned the properties of rectangles and we know that here both of these on the top and bottom will match, and then this left and right sides will match. I need to find my perimeter and I need to find my area. So I can say capital P for perimeter equals, and I could either do 2 plus 1.8 plus 2 plus 1.8, or I can use the formula, and my base is 1.8. So I could do 2 times 1.8. Again, the reason I can do that is because I have 2 distances here that are 1.8 plus 2 times my height, which is 2. And I have 2 heights that are 2, so that's why I'm doing 2 times it. And when I do that, I get 7.6. So I can come up here and I can say my perimeter is 7.6. And I do need to put units. Units are very important when talking about perimeter and area of figures. So you need to go and look at what units were used in the figure. I see feet, and perimeter is just the units. So I'll have 7.6 feet. Now I need to find area, so capital A for area. And in my area formula, I just do base times height. I'm multiplying the 2 different side dimensions, so I'll have 1.8 times 2. And when I do that, I get 3.6. So I can come up here, my area is 3.6. I do need to be careful for my units because area is always square units, so it's going to be square feet. You could say feet squared. Let's look at example C before you try some on your own. So for example C, I'm given a little bit different information. So I'm given the top and bottom here, so I know my base is 2.8. However, I don't know the other dimension. It's a question mark. So I'm going to have to find out what this other dimension is. And I'm given the area. So right away, I can actually fill in my area. My area is 9.8 square centimeters, because area is always units squared. I know my area, and I know one of my dimensions. I know the base, but I need to find my height. So what I can do is I can use my formula. Area equals base times height, and I can plug in what I know. So for example, I know my area. Right here it tells me my area is 9.8, so I can plug that in for my area. So I will have 9.8 equals my base, and I'm actually given my base. My base is right here, 2.8. So I'll have 2.8 to plug in for my base. And I don't know my height. That's what I'm trying to find. So I could say question mark, or I'm going to say H for height. So here's my equation. My area is equal to my base of 2.8 times my height, and I need to find my height. So notice H is the variable that I'm solving for in this equation. And this is a really quick one-step equation. If I want to isolate H or get H by itself, this is 2.8 times H. So to undo that, I would need to divide by 2.8 on both sides. And I'll get a height of, when I do 9.8 divided by 2.8, I get 3.5. So that means that my height here is 3.5. And if on the left it's 3.5, then that means on the right is also 3.5 centimeters. So now I have my figure completely filled in. And the reason I needed to fill in my heights here is because in order to answer perimeter, I need to add up all my sides. So now for my perimeter, and I guess I could show my work above here, using my perimeter formula, I'm doing 2 times my base, which is 2.8, plus 2 times my height, which is 3.5. And I can do that math really quick. If you want to type this into your calculator, you may. Just be careful. Make sure you use parentheses. And when I do this, I end up getting 12.6. And perimeter is just units. So I'll have 12.6 centimeters. Now on the back side, you have 4 U-tries. So I'd like for you to look at U-tries 2 through 5 and see what you come up with. Go ahead and pause the video. On U-tries 2 and 4, I was actually given both the base and height, so I had everything I needed to plug into my perimeter and area formula. So on U-try 2 for perimeter, I did 2 times my base plus 2 times my height, and I got 29.4 yards. For my area, I did base times height, and I got 51.3 square yards. On U-try 4, I did the same steps, and for my perimeter, I got 19.6 kilometers. For my area, I got 22.8 square kilometers. On U-try 3, however, I was not given both my base and height. I was given my base. My height here is a question mark. I was given my area, so right away I could fill in the 60 square inches for my area, and I had to use my area equals base times height formula in order to find this unknown height so that I could use it to add up the sides for my perimeter. So my area was given, it was 60. My base was given, it was 10. And I was trying to find my unknown, which was my height. So I ended up dividing by 10 on both sides in order to get my height, which was 6. And once I knew my height was 6 inches here, then I could add up my 4 sides, or I could do 2 times my base plus 2 times my height. And for my perimeter, I got 32 inches. On you try 5, on this one, I was still given my area. So I filled in my area, and right away I could put it in my table. However, on this one, I was given my height, and I was missing my base. My base was unknown. And so filled in my area, set it equal to my base, which is our unknown, what we're trying to find, times, so I used parentheses to indicate multiplication here, times our height, which was 8.1, divided by 8.1 on both sides, and I got that my base was 11. Then I had all 4 sides of my rectangle, so I could find my perimeter by doing 2 base plus 2 height, or just add up the 4 sides, and I got 38.2 feet here for my perimeter. Next, let's look at example D, our last example. And for example D, it says, find the area of each polygon by using the sum of areas postulate. Sum of areas. And if we look at the front side of our notes, for sum of areas postulate, we said the area of the parts must equal the area of the whole. Meaning we could add up all of these smaller areas and that will give us our total area. So in example D, it would be hard to find the area of this figure because we don't have a formula. We can't just do base times height for this irregular figure here. And so instead what we can do is we can split it up. And what I mean by that is I can see right here, I could split this into a rectangle here, and then I view it as I have like one big rectangle right here, and then this little skinny horizontal rectangle right here. So by splitting it up into 3 different separate areas, I could add up the area of each of these smaller rectangles. The area of the parts must equal the area of the whole. And so what I need to do is I need to make sure I have all the dimensions I need in order to find the area of each of these smaller parts. So if I start over here for this rectangle, I need to do base times height, and I actually have both my base and my height. So 3 times 4 here gives me 12. So this area is 12 units squared. I can make a note of that, 12u squared. If I come to this big rectangle here in the middle, I see that I have my base as 8, but I don't know what my height is. So I need to note my height. And looking here along the left edge, I see that from here to here is 6, and from here to here is 4. So that must mean that the whole way across here would be 6 plus 4, or 10. So my height there is 10. So that means in order to find the area of this rectangle, I'm doing base times height, or 8 times 10, which gives me 80 units squared. So now I've got 2 areas. I need to find my third and final area. And for the last one here, I have both my base and my height, so I can do 7 times 2, and I'll get 14 units squared. So then I can say that my area equals, and I'm going to add up each of my areas. So 12 plus 80 plus 14. When I do that math, I get 106 units squared for my total area. You now have 3 last U-tries, U-tries 6, 7, and 8, and there's not one particular way to do these, so take some time, see what you come up with. Go ahead, pause the video. Let's see how you did. On U-try 6, I split mine up into 2 smaller areas. So for this area, I had base times height, 10 times 8, so I had 80 square feet. And then for my other area, I had to figure out both my base and my height. And so in order to do that for my height here, I noticed that from here to here was 6, and here to here was 8. 6 plus 8 gives me a height of 14. And then in order to find my base, I noticed along the top was 24 and along here was 10. So if I do 24 minus 10, then that leaves this measurement to be 14. 14 times 14 gives me 196 square feet. Add up my two areas and I get 276 square feet. You try 7 was the most challenging because I split it up into 4 different smaller areas and added up those 4 smaller areas. There were different ways you could split up the figure. I guess let's start up here. So I started and I noticed that my base and my height, 12 times 4, I had 48 square units. For this tiny little rectangle right here, where it actually ended up being a square, I noticed that along the top, I had 12 units. Along here, I had 10 units. So 12 minus 10 means that this little length here was 2. And then similarly, looking along the right edge, I noticed that this length here was 10, and over here on the left was 4. 6 minus 4 means that this distance here had to be 2. So for base times height, 2 times 2, 4 square units. For my rectangle down here, I noticed that along the bottom, my base was 14, but I had to figure out my height to know my height. Along this side, I saw 10 units. Over here was 6 units, which means both of these here are 6 units. So I did 10 minus 6 to get 4. So now that I know that this is 4 units, 14 times 4 gives me 56 square units. And then my last area here, I noticed I had my base of 4. We talked about how this matches up here, 6 units, or you could double check over here along the side. 4 and 2 also gives you 6. So 4 times 2 is 24 square units. Add up my 4 smaller areas because area of the parts will equal area of my whole, 132 square units. And then very last you try, number 8, I split mine up into 3 different parts. So you had to notice the congruent tick marks. 1 tick mark and 1 tick mark means both of these measurements are 2 inches. 2 tick marks and 2 tick marks means both of these are 3 inches. Then I had my base and my height. So each of these areas were 6 square inches. And then along my bottom rectangle here, I knew the base was 10, but I had to discover my height. And so if I knew that this distance here along the right was 6 inches and this little piece here was 3, 6 minus 3 gives me 3. So base times height, 10 times 3, or 30 square inches. Add up my 3 smaller areas and I get 42 square inches.